Okay, so at 1B, they said we had to calculate, and because they were both just normal adding and subtracting, I could go from left to right. So your answer at B would be minus 12. Then at D, again, adding and subtracting, so we just go from left to right, and minus 55 plus 72 minus 104 will give you minus 87. If you maybe had an added step in between, it won't be wrong, okay? Then same thing at F, just normal adding and subtracting. Yes. 2.2. Yes, exercise 2.2. Okay, then at number 2, they said simplify the following. Now we said that when we add or subtract, we can only add or subtract like terms. Do you remember that? Meaning the unknowns must be the same. So at 2a, they say minus 15y plus 6y. Can you see they both have y as an unknown? So they are like terms, and I am allowed to go and add and subtract. Any questions up until there? No. Okay, can I skip? Okay, at D. Now at D, I'm quickly going to close it like that. At D, you will see we have A's and B's as unknown. So now you have to only add those that has A as an unknown. And you'll see that I underlined that in yellow. So 11A plus 22A, that gave me 33A. Then the minus 19B and the minus 12B were like terms because they both have B as an unknown. So minus 19 minus 12 gave me minus 31. And remember, your unknown stays B. Unknown does not change. Okay. Right. Then at F, same thing. But here I've got A squared B and then I've got normal AB. Remember, those aren't the same. So you'll see the A squared B's, I underlined those in green. So minus 15 A squared B plus 44 A squared B gave me 29 A squared B. And then I had to put together this minus 19 AB and the minus 61 AB. And that gave me the minus 80 AB. Okay. So basically all you had to remember here was like terms and then put those together. Right, the next one, at number 3, they asked you to write down the value of x that makes each of the following true. So basically I'm asking you to solve x. Okay, so over here, I took the x to the other side, and when I take this minus 150 to the other side, it becomes plus 150. So that's how I got to my next step. You guys find that? Okay, and then 0 plus 150 just gives me 150. Okay. Any questions there? Okay, now at D, minus 86 minus x is equal to minus 110. So the first thing that I had to do here is take that minus 86 to the other side, and then it becomes plus 86. Can you see that in my next step? Okay, now we simplify. That minus 110 plus 86 is going to give me minus 24. But what I want you to see here is that I've got a negative over there. And we don't want minus x is equal to something. We want to end with just x is equal to something. So how do I get rid of that minus 1 in front? I divide both sides by minus 1. Right? Okay, and when I do that, it means that x will be equal to positive 24. That part that I showed in yellow, you don't even have to write that down. You can skip directly from here to the final answer. Okay, any questions there? You good? Right. Ooh, that's going to stay behind again. You and that thing. Okay, can I skip? Yes, ma'am. No one copying? What are you doing? Raphael, did you do homework?
He's doing your homework now.
You're checking from the back of the book.
He's checking from the back of the book.
Right. At F, 5x is equal to minus 85. Now this is actually 5 times x, right? And I want only x, so I've got to get rid of that 5. And that's times 5. So if I take it over, it becomes divided by 5. Okay, so minus 85 divided by 5, and that's going to give me 17. Huh? Then at number 4, it says, which of the following are like terms? So to know which ones are like terms, I looked at the unknowns, and those that have the same unknown, they would be like terms. I did show you right in the beginning of that previous lesson. Do you remember?
Yes, ma'am.
Where we had the different scenarios where the one had brackets, and if I multiplied it in, it looked like the other. Okay, so at A, you would have 2AB and 8AB. Those would be like terms. Both has got an A and both has got a B. At B, 10A squared B and minus A squared B. They would be like terms. Remember, the coefficient doesn't matter. We only look at the unknowns or the variables. Okay, so this was the one that I was talking about now. At E, A times AB, I just want to check that I write it here. If I were to multiply that out, A times AB, it would give me A squared B. And the other one, if I multiplied this in, 2A times BA, it's going to give me 2A squared B. So can you see that both of these has got A squared and B as an unknown? So that is why they would be like terms. Okay. Right. Any questions? Right. Then, people, you also had to do, and we didn't have a lot of time, or I didn't go through this because it was load shedding. Do you remember? So you were supposed to go and copy down those notes. So I'm going to run through them, and you were supposed to have written them down already. So I'm going to just talk you through those, and so you can just have a look. Okay. Right. So the first thing that we said here is when we add or subtract, please remember the next two things. Firstly, you must use like terms. I can only add or subtract like terms. If the unknowns are not the same, you can't add them. Then they're already in their simplest form. Okay, the second thing here is after you added or subtracted the unknowns, please remember that the coefficients are going to change. The variable will stay the same, like you saw just now. 2AB plus 6AB just becomes 8, and the unknown stays AB. Okay, so the unknown or the variable does not change.
Yes, ma'am.
But when we multiply or divide, then we do not need to have like terms. You can multiply or divide anything with each other, no? But when we do multiply or divide, then it means that the unknowns or the variables are going to change. All right, so let's look at examples. The first example here is the minus 4x times the minus 3y. What's wrong? You still copying? Didn't you copy that from the other slides?
No.
Did you receive it or not?
I'm not sure if I copied that. I thought you had to rewrite the copy.
Yeah. You were supposed to. Okay, but I'm not going to wait now. I'm just going to skip through, and then if there's time, I'll go back, and then you can rewrite. Okay. So, who was mamming now? Yeah. Quickly go. Okay, so minus 4x and then bracket minus 3x. So what's written in between here is actually a multiplication sign. No, or times, yes. So, no, not a minus, no. What I've got to do is I've got to multiply everything in the first bracket with everything in the second bracket. So what I usually do is I first use the coefficients, meaning minus 4 times minus 3. And that's going to give me positive 12. Now we look at the unknowns. X times y becomes xy. So can you see that the unknown changed? No.
Yes, ma'am. I know.
Okay. Right, example 2. 4x and then 2xy. So meaning, do I only have to multiply that x with a bracket?
No, ma'am.
Because this 4 and the x is one term. So that whole thing, the 4x, the 4 and the x, must be multiplied with everything inside the bracket. How do we distinguish between terms? How can I say that that's one term? How do you know when a new term starts?
There's a bracket.
There's a, no, not a bracket. A what? I heard it.
Plus or minus.
A plus or minus. Yes. When you see a plus or a minus, it means a new term starts. But it doesn't count when it's inside brackets, meaning over here, because that minus was inside the bracket, it doesn't count. So how many terms would this be? Just one. No, because in between is written a multiplication sign, and that doesn't mean that it's two terms. It stays one thing. Good. Okay, so 4x times 2xy. So let's look at the numbers first, or the coefficients. 4 times 2 is going to give me 8. And then x times xy is going to become x squared y. Any questions there? Okay. Then the next one, minus 24x squared y divided by 8xy squared. Now over here, you could have left it like that, but we sometimes give it to you in the form of a fraction. So I just want to read it from this fraction. So minus 24x squared y, and then this line in between, that one, is actually, kyk nou wat se strooi van my kant. That line in between is actually seen as a division. Okay, so divided by, and then the 8xy squared. Okay, right, so if I wanted to do that, I am going to cancel out. Now when we cancel out, we do it up and down or across. That's actually on the next slide, so I'll talk about that again. But 8 will go into itself once, and 8 will go into 24 how many times? 3 times. Okay, now let's look at the x's. X I can take at the bottom, which means I can take only one of those x's at the top, so there would still be an x left. Then y I take at the top, which means I can only take a y at the bottom. So can you see at the top I have left minus 3x, and at the bottom 1y, or just y. Do you see that? Okay. Just take that away. Now the next one. 2x to the power 3, y to the power of 2 over 16xy. Again, we could cancel out. 2 will go into itself once, and 2 will go in here 8 times. X to the power 3, and at the bottom I've got x. Remember, we can only take the lowest exponent. No, which means that I can't take x to the power 3 because I've got 2 little x's at the bottom. No, so I can only take x. So if I take x at the bottom, I can also just take x at the top, which means how many would be left? 2. Then the y's, I take y at the bottom, which means I can only take one of them at the top. So what would be left? One of them. Okay, so that's how I get to the top part. 1, have a look, 1x squared y. You don't have to say to the power of 1. And at the bottom, just the 8. The rest was all cancelled out. Do you guys see how I get to my answer?
Yes, ma'am.
Any questions? None? Okay. Now, first look at that right-hand side note there. I said very important. At fractions, you can only cancel out if we have one term at the top and one term at the bottom. Meaning, if it was something, if there was a plus or a minus at the top, meaning I've got two terms, then you cannot cancel out yet. Okay, we're going to have an added step there, but that is for a later stage. Okay, right, now I can also give you the following: 2x divided by 8y, and then say times 16y squared over x. Now over here you must remember that I am allowed to have a look over here. When I cancel out, I do it up and down or across. Do you guys see? Okay, so let's quickly cancel out. So let's just see up and down at this first one. 2 will go into itself once. 2 will go into 8 4 times. Is there anything else here that I can cancel out? Okay, let's look at the second one. Can I cancel out anything at the second one? No, so then we try across. Now remember, I take this top one with that bottom one. Okay, that's what I mean with across. Okay, so can you see that this x can be cancelled out with that x? No. Okay, and now I take it across like this, so these two. What can I cancel out there? 4 will go into itself once, and 4 will go in 4 times. Okay, what else? I take a y, and I take one of those y's. So have a look. Okay, ours looks slightly different than what it is here, but the final answer is the same. Over here, you'd have 1 over 1, and over there, 4y over 1, and that gives me 4y. Okay, so sometimes, and that's what happened here, I didn't cancel out completely, or I maybe use different steps, and then, but you still get to the same answer right at the end. Okay, I think what I did here is 8 goes into itself once and 8 goes in twice. That's how I got the 2 and the 2. Okay, right, any questions so far? Right, then the very last one. If you get something like this, please make a note there. You cannot cancel out when we still have division. I have to first change that division sign to a multiplication sign. And when I do that, it means that these two are going to swap around. And it's always the fraction after the division sign that switches around. Okay, so nothing happens to the first one. Okay, so have a look. Can you see that it was 8y over x? And if I swap it, it becomes x over 8y. And why did I do that? Because the division sign became a multiplication sign. And now I can go and cancel out. So let's just cancel out up and down. X will go and cancel out with that x. Okay, nothing over here. Now we can cancel out across. 2 will go into itself once, and 2 will go in there 4 times. And that x, that y cancels out with this one, and this x cancels out with that one. So we end up with just 1 over 4. Any questions? Okay, right. Then you guys got homework. Number 1, 2, and 3. Now, just in case some of you might have been a little bit unsure about what to do and how to do it, now there should be no questions. Is there anyone that maybe has got a question? No. Okay. Right. So if you look at exercise 2.3, you are now going to add to that homework number 4 and 5. At 4 and 5, people, very important. I'm going to write it down here. At number, just put that on silent, please. At number 4 and 5, please remember that BODMAS is very important. What is BODMAS again? It tells us the order in which your calculations must be done. Right? So you will see that they did not give you brackets. you've got to look at, if I've got addition, subtraction, multiplication, and division in one sum, what's more important? What must I do first? There is no brackets. Multiplication, division, addition, and subtraction. Which one goes first? The multiplication. Right? So then you first get that answer. Okay. And then we go to the next step. What's now important? The division. After I did that, then what's more important? The addition and subtraction. Okay. So you guys can start with number 4 and 5 now. We're not going to mark number 1, 2, and 3. You can start with that now. Please remember about FODMAPs. Okay. That is it. Thank you.